Hey everyone, in this video we'll learn all about functions, and before we get into what functions are, we have to talk about what a relation is. Relation, and a relation is just a set of ordered pairs. So if we refresh our memory on what an ordered pair is, it is just a pair of numbers that have an x-coordinate and a y-coordinate. So this is an ordered pair right here. And a relation is simply just a set of ordered pairs. So if we if we write an example, let's use curly brackets, and let's go ahead and write 1, 2, 3, 4, and 4, 7, and close the curly brackets. Okay, so this entire thing right here, this is a relation. Now let's take a look at what's inside the relation. We have 3 ordered pairs, so 1, 2, and 3 ordered pairs. And each of these ordered pairs, if you take a look at each of them, they each have an x-coordinate right here that I'll underline in green, and they also each have a y-coordinate that I'll underline in orange. So right here, all the greens, all the x-coordinates, 1, 3, and 4. And then we have all the y-coordinates in orange, 2, 4, and 7. So let's actually talk about the x and y coordinates. They have special names. So the domain, and the range. So the domain is the set of all x-coordinates. So let's open up the curly brackets, and let's go ahead and write them down. We have 1, 3, 4, all the ones underlined in green, all the x-coordinates. And then we'll close the curly brackets, and that is the domain of this relation. The domain of this relation is 1, 3, and 4. That's the domain. And let's talk about the range. So the range of this relation is all the y-coordinates, the ones underlined in orange. So what are they? They're 2, 4, and 7. So let's write them down, 2, 4, and 7. And let's close the curly brackets. And that is our range, 2, 4, and 7. So the domain also has another name called an input. So input. And the range also has another name called an output. Input, output. So the domain of a relation, that's the input, and the range of a relation is the output. And now let's actually also talk about their other names. So another name for the domain or for the input is the independent variable. So independent variable. Independent variable. And another name for the output or the range is the dependent variable. So dependent variable. Independent variable, dependent variable. Input, output, domain, and range. So those are all the names. And the domain or the input or the independent variable, they are just the x-coordinates of the relation, the ones underlined in green. And the range or output or dependent variables are all the ones underlined in orange in this relation right here, 2, 4, and 7. Great. So now let's actually talk about functions. So a function is a special type of relation. So a function is a relation. It's a relation where each input only has one output. Only has one output. So a function is a relation where each input only has one output. That's what makes a relation a function. So our question here is this relation right here that we started with, 1, 2, 3, 4, and 4, 7, is this relation a function? Well, let's go ahead and write down their inputs and outputs. So let's go ahead and actually just make a little table. We'll make a column for inputs, and we will make a column for outputs. So the inputs are all the x-coordinates, all the ones underlined in green, 1, 3, and 4. 1, 3, and 4. So let's go ahead and write them down. So all the inputs are 1, 3, and 4. And now all the outputs up here, they are all the ones underlined in orange, all the y-coordinates, 2, 4, and 7. So let's write them down, 2, 4, and 7. And let's see what they relate to. So if we go back up, this first ordered pair right here, 1 relates to 2. 1 relates to 2. So if we input 1, our output will be 2. So we'll draw an arrow from 1 to 2. And up here, 3 relates to 4. So 3 relates to 4. If we input 3, our output will be 4. Great. And in this last one, 4 relates to 7. So 4 relates to 7. So that means if we input 4, we will output 7. And there we go. If we take a look, all of our inputs, 1, 3, and 4, all of them only have one output. For number 1, the only output is 2. For number 3, the only output is 4. And for this number 4, the only output is 7. None of them have more than one output. So this relation right here that we started with, this is also a function. So this is a function indeed. Now, let's go through a quick example of a relation that's not a function. So let's say we had this relation right here, and let's use some curly brackets. Let's say we had 1, 2, 1, 3, and 3, 7. Close curly brackets. So again, what are all of our input values? What's our domain? Well, it's all of the x-coordinates, which I'll underline in green, 1, 1, and 3. And what are all our y-coordinates, our output, our range? It is all the y-coordinates right here, 2, 3, and 7, which I'll underline in orange. So let's go ahead and make that little table again. So we have our inputs. It's 1, 1, and 3. And then we have all of our outputs. So all of our outputs, it is 2, 3, and 7. Okay, now looking at this first one, 1, 2, that means 1 goes to 2. And let's actually condense this a bit. You notice we have 2 1s. So when we have duplicates, we can just combine them. So we'll just have one single 1 right there. And then we'll go ahead and move this 3 a little bit further up. Okay, there we go. So no more duplicates. Okay, so back to this relation right here. Our first ordered pair is 1, 2. So that means 1 goes to 2. And then our second ordered pair, 1, 3, that means 1 goes to 3. And then our third ordered pair, 3, 7, that means 3 goes to 7. So as you can see right here, 1, if you take a look at 1 right here, our input, 1, it has 2 outputs. 1 has an output of 2, and 1 has an output of 3. So this one has 2 outputs right here. See, there are 2 outputs. So this one has 2 outputs. This single input, 1, has 2 outputs. Therefore, this relation is not a function. So this is not a function. It's simply just a relation that is not also a function. So this relation is not a function. Now let's just go through one more quick example. Let's say we had this relation, and let's use some curly brackets. So we had 1, 2, 3, 2, and 7, 3. Close curly brackets. And again, we'll do the same thing. All of our inputs are these x-coordinates in green, and all of our outputs are these y-coordinates in orange. So we will write down our inputs, and our inputs are 1, 3, and 7. And we will write down our outputs. Our inputs are 2, 2, and 3, so 2, 2, and 3. And we have a duplicate, 2 and 2, so we can just combine it to just a single 2. And we'll go up here. And let's go ahead and draw some arrows. So in this first ordered pair, 1 goes to 2. So 1 goes to 2. And in the second ordered pair, 3 goes to 2. So 3 goes to 2. And in this third ordered pair, 7 goes to 3. So 7 goes to 3. Now, check this out. 1 and 3, both of these inputs both go to 2. So this output right here, 2, has 2 inputs, 1 and 3. However, this is still a function. This is a function because outputs are allowed to have more than one input. That's fine. It can still be a function. All that matters is that each input doesn't have more than one output. So 1 only has one output. The only output it has is 2. And 3, the only output it has is 2. And 7, the only output it has is 3. None of these outputs have more than, or none of these inputs have more than one output. So this is still a function. Even though some of these outputs have more than one input, that's perfectly fine, as long as the inputs don't have more than one output. And that's what makes it a function. So let's talk about how we represent functions. So let's say we want a function. So we want a function of x. So this is what function notation looks like. So for this function, let's use the letter f, and we are going to use x as the input right here. X is going to be our input. So function notation is written like this: f of x, f parentheses x. So this is read, how you read this is f of x. That is how you're supposed to read this, and this represents a function. F of x is a function of x. So in other words, x is the input right here. This right here, this x is the input. So I want you guys to think of a function like a machine. So you put an input right here, you have an input, and you put it inside this function. And then you will get an output. So you will get an output. So you have an input, that's x in our case, and you put it inside this function right here. So this function, it's a machine. You put the input x into this machine, in this function, and it spits out something new. It spits out whatever f of x is. And that is your output. So let's go through an example. Let's say we had a function f of x that represents money, how much money we get as a function of time. and that's what f of x is supposed to represent. So in other words, x right here, x is time. Let's say hours. In hours. And f of x, right here, f of x is money made after x hours. After x hours. So let's draw a table. And in this table, we are going to have x in one column, and we'll have f of x in the other column. So x is our input, or our domain, or our input, and then f of x is our output, or our range. So let's say we had numbers 1, so let's say 1, 2, and 3, and then f of x, so the one corresponding to 1, let's say it's 23, let's say this one is 26, and this is 29. Okay, so what does this mean? What does f of 1 mean? What does f of 1 equal? So think about this. This is f of x, and x represents what we're inputting. X represents time in this case, how many hours. So what does f of 1 mean? That means how much money have I made after 1 hour. So how much money have I made after 1 hour? That's f of 1. And f of 1, well, f of x right here, if x is 1, then what is f of x? It's 23. So f of 1 is 23. So how I want you to think about this is this function f of x right here that we've made, you put in a 1 and it spits out a 23. That is what this function does. Okay, so what is f of 2? Well, we have 2 right here, our input, so we're inputting 2, and we're getting out, it's spitting out a 26. So f of 2 is 26. And you could probably see right here, f of 3 is 29. So f of 3 is 29. So f of 3 is 29. Let me just write that again, 29. Good, now what does this mean? Well, we defined f of x to be a function of how much money is made after x hours. So f of 1 is how much money we made after 1 hour, so we made $23 after 1 hour. F of 2 is how much money we made after 2 hours, so we made $26 after 2 hours. And then f of 3 is 29. That means we made $29 after 3 hours. And that is how functions are supposed to be used. Now, we can also represent this function in algebraic form as an equation. So let's write the equation for this function. F of x equals 3x plus 20. This is the function for the equation, or this is the equation for this function. F of x equals 3x plus 20. So now how do we find f of 1? Let's find f of 1. So f of x, and let me make these different colors. So f of x equals 3x plus 20. Okay, so what is f of 1? So f of 1 equals, and what you're supposed to do is when we're inputting 1 for x, so let's just write 3x plus 20, 3x plus 20, and you're supposed to find wherever x is, so there's an x right here, and you're supposed to substitute our input. So our input is 1, so we're going to substitute this x for 1. So 3 times 1. And then we'll go ahead and evaluate this. What is 3 times 1? 3 times 1 is 3, so 3 plus 20. And then what's 3 plus 20? that is 23. So f of 1 equals 23. Okay, f of 1 equals 23, and that's what we had on our table right here. Let's find something that we don't have on our table. Let's find f of 5. We don't have 5 over here in the x column, so let's go ahead and find that. So let's erase all this over here, and let's go ahead and find f of 5. So f of 5 equals, so 3x plus 20, so 3 times 5 times 20. And let's just go ahead and evaluate the same way. What's 3 times 5? That is 15. So 15 plus 20. And what's 15 plus 20? That is 35. So f of 5 equals 35. That's what f of 5 equals. So that means after 5 hours, we will have made $35. So that's how functions work. That's all about relations, all about functions, how to identify a function, how to read them off of tables, how to algebraically evaluate a function given a certain input, how to find the output. So that's all about how functions work. I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.